this is our lecture third for network science and its applications for the different sustainable development goals. So far we have seen that there are 17 SDG goals, that is software development goals, and how network science with its different domains can cater to this particular field. So we have seen that how not only network science along with the different of its domains and subdomains, but also how the different analysis and other analytical techniques can be applied for certain sustainable applications. So the first one that we saw was on network centrality. So network centrality allows us to see how influential a particular node is in a given network. So in this context, we have seen the degree centrality, the closeness centrality, and the betweenness centrality. So these are the benchmark centralities, but apart from that, there are many other centralities like cross-click centrality, farness centrality, eigenvector centrality. So each of the centrality measures have their own eminence in the real world networks. So we know that what is the relevance of the networks from the last few lectures, that it's the nodes that reflect the real world entities. It could be people, it could be places, okay, it could be online social network profiles, or it could be the places in the transportation network, right? And the links are the connectivity or the belongingness that reflects between a pair of nodes. So in the screen you can see that there is a graph, a connected structure, wherein there are some nodes that are marked as A, B, C, D and so on, and some links are there. So each of the node has its own relevance. So for example, a node that is having highly compact neighborhood, that is maximum number of nodes in its immediate neighborhood or immediate vicinity, is said to have the highest degree centrality. There are some nodes which are like well positioned in the network and the information can travel, or any kind of content can travel from that particular node to other nodes in the network in a very uniform manner. So such kind of nodes have better closeness centrality. Then there could be some nodes with higher betweenness centrality, which are acting as the bottleneck node or the bridge nodes between two or more bigger networks. Okay. So this way there are different centralities and they are associated with a particular graph. So it depends that for a particular application, what kind of relevance we are looking for, and likewise we can deploy the particular centrality metric to our connected structure. So this connected structure is as of now we can call it a network or a graph, but the difference we discussed earlier also, that when we are studying the connected structure in the modeling form, we call it the graph, and when it becomes implemented in the real world system, it becomes a fully functional network. So now we will understand that what is the diffusion across these kinds of networks. So we try to analyze how the content travels, how the information spreads. So it could be the information or it could be any content. For example, if we are talking about the biological network, it could be the propagation of the viruses. Okay. So any kind of content given a underlying network structure, how it is going to diffuse around, how it is going to propagate across the other nodes in the network. So this is the topic which is called information diffusion, which is used for analyzing the content virality. So if we study the significance of the diffusion, that is why we want to know about diffusion, the first and the foremost thing is to understand the spread of the network. Whenever we have some information or some informative content with us, we have a tendency to spread the word. So diffusion allows to spread this network across many other nodes. So this networked information is required as you can say important idea or a viral concept or a innovative belief, or it could be a newly launched product or anything, any idea. So now diffusion can also be used for analyzing the user behavior. Now we have spread the information and we want to know that how the people are reacting on that information. So what is their behavior, what is the response, what are the feedbacks associated with it. Then further we can also analyze the sentiment associated with it. And sentiments are not always binary in nature, that is good or bad, but it can be seen from a context. So given multiple contexts, we can have different behavioral analysis to a particular content that has been spread across the network. Also we can see that how this spread of information has benefited to the crowd at large, to the target audience at large. So is it of benefit or loss? So this benefit or loss can be in terms of monetary value, or it could be some kind of social value or some information value. Also there are certain constraints while the information is spreading. So we can also study such constraints and challenges associated, and also we can manage the resource assignments, or you can say that how we want to engage our crowd, our target audience, or you can say the community or the connected community in the socially connected network. So this is the significance of diffusion. That is why should we study diffusion. Now when we are studying diffusion, there are certain number of stages, you can say, that comes across during this particular phenomenon. So first one is the initiation phase. So in the initiation phase, there are certain profiles or nodes that tends to trigger the diffusion process, that is the spread of the information. So whenever information or a content is going to spread in the network, it has to erupt from somewhere, it has to start from somewhere, get triggered from the network. Some nodes of the network needs to be the triggerer. So it could be just one node, or it could be a set of nodes. So this node is sometimes called the triggerer, or you can say the seed nodes in the network. Then there are other nodes maybe in the nearest vicinity of the triggerer nodes, or maybe some hop distant nodes that act as whether they should accept the information, or you can say acknowledge the information that is being spread by the triggerer nodes or not. So this is called the adoption phase, and the nodes have the liberty to either adopt or to reject. So they either will accept the diffused idea or will reject the idea. So if they are accepting the idea, they are kind of acting as the relay nodes or the spreaders. So they have themselves adopted, and then they start the spreading process. So a node that is adopting in a positive manner may spread in a positive sense, and vice versa. If it is accepting the information in a negative manner, then there could be a negative spread of information. Now sometimes when this diffusion process is going on, apart from in which context the information is getting spread, for example, say a product is launched by a company, and some may have positive reviews and some may have negative reviews, and as the diffusion process continues, this particular process of spreading of positive and the negative feedback associated with that product will also tend to increase. But sometimes there are also situations where fake information or misinformation they start spreading. So when this kind of node starts, this kind of disinformation or misinformation starts spreading, that is the information that has no basis, or sometimes the information has got distorted, that is your disinformation, then there has to be certain algorithms to be drafted, and some function has to be deployed to check how this kind of fake news can be stopped by the spreader nodes. So there are several containment strategies that can be applied onto these kind of spreader nodes that is spreading the fake content, and that way we can contain the wrong information in a particular closed community, and then we can stop the spreading of such kind of fake news. So once we have the stages with us, we know how the nodes are reacting. So a same node can be a the adopter and the spreader, but triggerers are the specific kind of nodes that initiate the information process. Now the second, the subsequent part is the factors that are going to impact the diffusion. So the first thing that can be seen on the screen is the information recency. How much information, or you can say the informative content, is fresh. So is it the case that the information had relevance maybe some 3-4 days back, and now the relevance is not there? So for example, if the AQI was very high, say maybe 7 days from now, and the information is coming after 7 days, so the relevance is not there. Okay, so precautionary measures and all, they should be taken when the information is live and fresh. So when the information is getting diffused in the society, in the the societal network, then it has to be fresh. The information should be recent. Next one is the heterogeneity patterns that is present in the connectivity. So the connectivity could not be just based on just one criteria. Say the links that are there in the network, it is just not that it is because of the belongingness, but also it could be because they are interacting with the content. So belongingness could be one part, interactivity could be one part, activity could be yet another part, that is someone has posted the content and there could be few people who are commenting on it. Someone could be just liking the content and scrolling it. So there are different ways in which the links in the graph can be drawn or laid out. So based on each of the type of link, the connectivity link, the pattern of information spread is impacted. Next is the clustering, that is what kind of connected community is formed, how big is that community, how strong or weak connections are impacting on the information spread. So these all things are associated with the clustering part. And also the last but not the least, the time of the node creation. So node creation means here, node is what? The real world entity or the profile. Okay, so it could be a real world person's profile on the internet, or it could be a post created by him. Okay, or if it is any network on the social physical world, like the telecommunication network and all, then it could be a particular system in that particular telecommunication network. So when the post is created, is also playing an important role that how the information is going to spread across. So you can see the graph. So here the graph is like a S-shaped graph. So initially the start of the spread of the information is slow, depending upon whether the triggerer node is one or few or many, and gradually as the number of adopters increase with the with the time, then it starts reaching the curve of the graph, it starts reaching the saturation point, that is now all have adopted or have at least the idea of what is being going on in the society. The next thing is the factors influencing the diffusion process. So it could be the mobility, that how people are moving across in the physical world. So are they moving from one nation to another, one city to another, and likewise the information that they are going to get will be bit different. How they are interacting in the socially connected world, that is the social interactivity, is also one important thing. Then the change of similar behavior. So maybe two or more people are now having a kind of affinity towards a particular say product, like maybe some kind of electronic gadgets or so, and maybe after some time their behavior shifts to some other brand of product. So this way the similarity of behavior has the tendency to change, and this is going to reflect the target audience in the market. And especially in the commercial networks, this plays a very important role, that how fast the network is going to get saturated with the information. So these are the different factors that are influencing the diffusion process. Now let's see one benchmark model of diffusion, which is called the BAS model. So it has two states, as you can see, marked as 0 and 1, or you can say as non-visited and visited. So there could be some examples if we take up quickly, like I have used a product and I have not yet used a product. So if I have not used a product, I am not in a position to comment on its usability or performance. So I at present will be at the state 0. Once I have used the product, then I am in the state to comment on the product, comment on its usability, on its performance and all. Similarly, if I have not seen a movie, I am at stage 0, and now if I have seen a movie, I am able to recommend it or not recommend it to my friends. So similarly, catching a viral infection and getting recovered from it. So all these are very simple examples of the transition from the state 0 to 1, the state in which we are not knowing a particular thing and then we are acknowledging a particular information regarding some idea or concept or any new product. And here you can see the reverse transition is not possible. So if you have used a product, you cannot say that I haven't used the product. So you have used the product, so the state goes from 0 to 1. There is no coming back from 0 to 1. Obviously, there are certain instances also, say for example, if I modify this catching a viral infection, so it could be from 1 to 0 also there could be a transition that shows that now recovered. So from 0 to 1 catching the viral fever, and then from 1 to stage 0 getting recovered with the help of some medication. So such kind of bidirectional diffusion is also there, and with multiple states and bidirectional transitions are also there, but these are all like your very complex diffusion networks. So what we are studying here is a very basic benchmark model that forms the basis of many other diffusion models. So let's dive more deep into this. So with the two particular states, we have three parameters. The first is the rate of spontaneous innovation, and the second is Q, the rate of imitation. So P is like the triggerer, that what is the rate at which the triggering nodes are being deployed, and Q is the rate of the adopters, that how quickly the nodes in the immediate vicinity or the nodes in the connected infrastructure are adopting the particular information. F of t is the fraction of population who adopted state 1, that is the final state of course in our case, by the end of time t. So if we want to know after a time t is elapsed, how many people or what fraction of the population has actually shifted from state 0 to state 1. So, with these three parameters, we have the Bass diffusion model, which looks like this. So, it is a diffusion equation, wherein the left hand side, it shows the rate of change in the diffusion with respect to time t, and it is formulated with two terms in product. So, the first term is basically showing how the people are still in people are getting the adopting the idea, and they have kind of knowing the concept, and are have like transited to state 1. And the second term is they are in the state 0 and they are yet to get influenced in the particular diffusion process. So, for state 1, there are two terms basically. The first one, P, is the change by spontaneity. It means that there are some people who have just like that, they have accepted the idea because they are our triggerers, the seed nodes. And the second term in product Q of Ft, it means that they are in the process of changing by imitation. By imitation could be like getting the feedback and deciding to change or not change. Okay. And finally, whatever population is left, that is 1 minus f of t, is demarcating the state 0 population. Now, if we try to interpret this model, then we can see that this is also a kind of S-shaped model, and naturally the parameter Q is more than parameter P. That is, the number of triggerers in the network system is very less. Normally it is like maybe 1 to 2% of the nodes in the whole system are the triggerer nodes, because obviously not all people would like to volunteer for triggering a particular information. All will have this idea of getting the feedback first and then try out for the using the product, or taking a particular idea, or it could be anything. So, people mostly they rely on the feedbacks received from their peers. So, there are less number of triggerer nodes. So, P is naturally less and Q is more. It depends that how much the Q is more, and that is going to reflect in the sharpness of the S curve. If the Q value is much more than P, then you will get a very sharp S curve that is moving towards the saturation point. Otherwise, it will be a slanting S curve. Now, so this slow start depends upon the parameter Q, the parameter P in the first place, and then with the help of the parameter Q, the transition is reflecting a slow transition or a fast transition. So, the diffusion trend largely depends upon how the parameters P and Q are set. Further, we can see that if we are solving this equation, then you will get the final solution f of t as given in the expression on the screen. So, in solving the equation, we can find out that after a time t is elapsed, how many population are impacted in the system. So, the next study that we will see in very sooner is how to use these network science concepts along with case studies with some real world large networks and complex network structures. So, we will take up the online social network case studies for this, and these are the references to more explorative work if you are interested. So, many thanks for listening to the lecture. I hope it was very useful for you. Thank you.